Hello, everybody. I'm going to use my slide for this one now. We're talking about the CocoaPods frameworks. This is something that most of you will have heard of, but we're going to go into both the details of what the actual transition was for CocoaPods frameworks, and then a little bit of advice on how you could do it yourself, because we've got some good pragmatic time from when we've had to transition applications to frameworks. So CocoaPods is a very large amount of contributors, but more importantly, he's Marius Rackwitz, and he did all of the actual Swiftification and frameworkification of CocoaPods. So that was going from like the old way to the new way.
And he's Orta Therox. Everybody just knows him as Orta on Twitter. And he used to introduce himself as doing just the design work and being the design dictator, but that's actually not right. He has done so much more stuff for CocoaPods, like CocoaDocs, which is a huge project on its own, and maintaining our websites, and not just the design side, but a lot more about it, and backend side stuff, and so much more. A lot of plugins. Some weird plugins, but yeah.
I do all the
some really cool stuff.
Yeah, whenever it's like frustrating that CocoaPods won't do something and I have to wait for a release, it's time to make a plugin for it. It's a beautiful structure for doing this kind of stuff. So, what is CocoaPods?
So, CocoaPods is primarily a dependency manager, but also?
It's a community though, and it's really important about that part. Like, it's very easy to just think that a single tool can allow you to just do something, but one of the cool things about CocoaPods is it allows a lot of people to interact. In 2013, it was one of the most it had the most amount of committers to a single repo on GitHub, which is huge. That meant that at that point, we were the only people actively using GitHub as a source for like individual contributions. So it's a great reflection on how big the community is in terms of like what people are doing with it, and that is also reflected in the complexity of the tool. But it's existed for 5 years now, and it's like right, and it's stable, mature. It's pretty stable and it's pretty mature by this point. So in order to like talk a little bit about frameworks, we're going to talk a little bit about like some of the terminology. So first up, we have this is an Xcode project. You may have seen one of these before. We're gonna right. We want to talk a little bit about workspaces. So in general, the workspace is the bit that you see on this side. That's where all your project is actually kept and all your files and your groups. We're talking a little bit about targets. So they are like the apps or the extensions that you normally have in your project. And then a little bit later, we'll be talking about like copy build phases or resource build phases. And you can normally get to these when you click on a target and you see build phases. So CocoaPods does a few of its own in there instead of just the normal Xcode ones. So we just wanted to make sure that you guys knew all the bits that we'll be talking about. All right, you're up.
So, yeah, 5 years. That means for us also a lot of integration history, like frameworks. They have not been there forever. Before frameworks, we had static libraries, because static libraries were been the common denominator until iOS 7, because until iOS 7, they were not available for iOS, at least not for the App Store. You could use them effectively, and standard frameworks were dynamically linked, but you couldn't distribute your own frameworks with your app bundles. So yeah, we used them for the integration, because they were available on OS 10 and iOS, which were the only both platforms we had to support back then. Yeah,
Oh, 2 platforms. Could you imagine?
just 2 platforms. Yeah, and what are static libraries? It seems to be obvious, but little question to the audience here. Please raise hands. Who of you would think they could explain how static linking works, or a static library is linked? Okay, I see some hands raised. So actually, it's a trick question. static libraries are not linked at all.
Ta-da!
So it's not that obvious here in the main page of LD, but static libraries are just a collection of object files, and object files are compiled source files with still a lot of meta information, and the machine code you have there is independent from its position, and some other stuff you have to know in detail, but they are not linked. They're just compiled object files. And how we get there? When we build our source code with Clang, we get the object files, and those object files are put into runlib, and it's making an archive out of them. An archive has a table of contents saying which object file lives at which position in the WoW file, and keeps and maintains the file information, how this object file was originally named. And we do this for every architecture, and then we use Lipo to archive them all together again to a fat binary. So, and when we built an app with that, this could look like that, where some simplifications are applied here for the sake of simplicity. So we have here a library BananaKit, which has a dependency to the other library Monkey, and a CLI tool is our program we want to build, which depends on both of those libraries. And when we build this program, then it's rather simple. We just put everything together, compile it, and then link it. Yeah, and that's our program. So for CocoaPods, we set up the Xcode project so that everything works like that. So we set up static library targets. But in addition to that, because static libraries do not contain or support anything like resources or stuff like that, like even other associated files you would need, for example, with core data, you have core data models and stuff like that. So CocoaPods has solved that with an additional build files, which is used for the integrated target, and this is named CocoaPods resources build files, and it's nothing different than a run script build files, which executes a little shell script, which lives in a separate shell file for the reason that it's easier to regenerate the separate shell file instead of having that living in the Xcode project, in the pods Xcode project, because that would cause bigger changes to the integration, and it's not that easy to overview if you have diffs with that, and we want to make it as easy as possible if you check in the pods project. So yeah, but that's all about the integration scenario with static libraries, and what we needed then were dynamic frameworks, because they are required for Swift. If you want to build with Swift from iOS 8, for iOS 7, there are distributions from Apple of the standard libraries as static libraries, but they are only available for iOS 7, so upwards. So if you want to use, want to target a higher platform, you will need to use the dynamic libraries, and that's very likely the way for the future, especially when Swift once reached that point where it comes bundled together with the OS, like, or other standard libraries like Foundation, where you used to dynamic link them. So yeah, we adopted the dynamic linking with the frameworks together. So first of all, what is a framework? How it looks like? So if you tap into it in the Finder in your build products, it's just a bundle, a file bundle. Because it has this file suffix, it is displayed in another way, and Finder knows some meta information about framework. and if you right-click on it, you can actually tap into it and browse it like any other directory. And here we have the full expanded tree, and we see at the top we have here the example of a very popular networking library, LMFire, which is like if networking for Swift, basically. And we have the first entry is the executable. That's basically a dynamic library without the file suffix div-lib, because that's just clear that some executable through living in the framework and having the same name like the framework. Actually, there are static frameworks, and then you can have a static library at this place, and it just magically works, which is kind of undocumented that it works that way, but that just as side information here. And then we have the headers, and we have automatically generated bridging header for Swift, or for Objective-C to interface the Swift parts of the model. And we have the umbrella header, which is important together with the model map, because it's responsible for defining the public interface. So everything which is the umbrella header is referenced in the model map, and everything which is transitively imported by the umbrella header is part of the public model interface and available for everything linking against it, and that plays a role when using model imports, which are available with @import for Objective-C and the standard case for Swift, but they are done based on what we see below as in the directory models, and then LMFire Swift model, and there we see also that there is some extra documentation information which is used by another part of the tooling, and those are here obviously platform specific, as we see by the file names. In addition to that, we have the info plist, which contains some meta information, as we here see. There is information like the version and the copyright. And if you have seen that before in the umbrella header, which is generated by default, there's a foundation export, your library name, version, and it's a constant. Good to know is that the version information from the info plist file is pulled at build time of the framework and read, and a little C file is generated, and so the constant is actually not read at runtime from the info plist, but is part of the binary and is compiled into that, because otherwise it would take a long time to assess the version information, and that wouldn't be really that helpful. And here we see again these information are only necessary for import and linking. They are not there anymore if you distribute your app for App Store builds and stuff like that, because they would give more information about what's going on in your libraries, and there could be some protected information in your framework documentation if you share code across your app and your extension or stuff like that. So that's ripped out. But what's dynamic linking, or what are dynamic libraries? And in comparison to the static linking, we see here from the main page this important detail. It's a final linked image, so the linker run on it. So here again, this little diagram, we compile our source code, and then we run the linker over it, and then we have the Mac object file, which has a header with some meta information like dependencies and stuff like that. And we repeat this whole process again for every architecture we need. And then again, here a little demo for it. We see now with some Swift files here, the same different artifacts, and in the first step we compile Monkey Swift, and then we export some symbols of it. We have exported it in our public interface. And then as next step, we compile BananaKit. And when we compile BananaKit, we make use of some foreign symbols. And one of this is mkmonkey. And we have to link that to our Monkey Swift, the library, and have to annotate where it comes from. And then we have this Orta symbol here, which is array, and that comes from a Swift standard library, but I leave that out of scope here for sake of simplicity again. Yeah, and then again we compile our main program, and obviously we can't export there any symbols because the program is linked by itself, and no one links to a ready program, which is built for running. So yeah, then we have to resolve the symbols here again to both of our libraries, and yeah, there you go. Here again, what has to happen with frameworks, because we link them and annotate in our macro header about the linking, that there are other dynamic libraries or frameworks around. We have to embed them and make sure that they are available on runtime, so the dynamic link can be resolved when the program runs. So they have to be embedded in the app bundle in the frameworks folder. And this build files we have here is just the usual copy file build files, and it is named. You can just arbitrarily rename build files in Xcode, and the destination is set to frameworks from the combo box. Yeah, but that's not enough for CocoaPods. We have some special possibilities. We have configuration-dependent pods, like here, little demonstration how that would look like for the pod file. That makes sense if you want to include some frameworks which are not suitable for the App Store, like some user testing or stuff like that, something you can't ship in the App Store because Apple has some obvious restrictions, and some not that obvious. So we needed to come up with a script for that, which allows to embed the pods, just those which are active for the current build configuration, because Xcode is not able to allow us a setup like that. So that's the reason why you will find in an configuration a new build file which looks a bit different than the default case if you would set it up yourself. But what is happening there is still the same. Headers are stripped, and the frameworks need to be signed. So everything is signed by itself, like frameworks are assigned individually, and your app executable is assigned individually. Yeah, that's the way it is. Okay. And now a little comparison. We have seen static linking before, and we have now seen dynamic linking. And now from the perspective of the new thing we have and have built, what is better about it? So frameworks especially are easier to distribute and integrate into the app when once they are built and compiled, because they bring everything together and they allow to bundle resources, and they have really a separate name scope. So it's even at runtime you still see the difference when referencing to a bundle, for example. You have a really separate name scope. So another advantage is they allow to reduce the file size of your whole app bundle if you share the same framework across your app and your extensions, and reuse it in both places. But if you have to use different API availabilities, like on iOS, there is this restriction for that the extension API may only be used in extensions where you have limited access on, for example, UI application. Then you need to ship 2 versions, which has not been available since the very beginning of when extensions were introduced. So I can't even say exactly, but you can have a separate frameworks folder in your Apex where you can have separate frameworks so that you can have 2 versions of the same framework. Yeah, and what I said before, you have this really separate bundle, which also allows you to access resources by name only from your framework bundle, and you don't get by accident any other framework or any other frameworks resources or the app resources just because they have the same name or you have name clash at build time. So that's nice about it. But there's some disadvantages because you have as dynamic libraries a final linked binary. You limit possibilities for optimization because it is linked at that time when you build it. It could be even on a different computer if it's some closed source third-party library, which is rarely the case for CocoaPods. Exactly. Yeah. So through which falls in the same category, that code stripping is limited. With static linking, you can just import the object files you actually need, and object files which are not needed are not included, which is a bit difficult to say as a real disadvantage, because with Objective-C you have in the most cases all of the object files included, or at least the vast majority of them, because the compiler is not able to figure out at compile time what is called and what is needed at runtime, because it's a dynamic language. Yeah, but something very important to mention here is the increased load times you will have, because when you do it at runtime, there's some overhead for resolving the dynamic links to other binaries. Okay, and I go over back to Orta.
Yeah, get control again. So what that means for generally for CocoaPods is we have to support a bunch of different things, and we ended up getting a few freebies like the Clang modules. In order to pull it off, we had to obviously extend the code that you would write when you're using CocoaPods. So in essence, that was things like use frameworks, which is just a thing that you say in your pod file that will then start using frameworks. We did that initially to make sure people knew that they were using frameworks, and you've been pitching lately that we should remove it eventually.
Well, we could recommend to use it in some cases. We could be a bit smarter about it, but yeah, I think we need still both integration scenarios. So it makes sense to have it in the pod file and to have to use it explicitly. Yeah. At this point.
And that's been really useful. We've obviously had to work around tons of Apple's tools because they're as good as you expect them to be around using third-party stuff. Woo! And code signing has been really, really, really difficult. Like even months after we've shipped all this stuff, we're still like seeing problems with code signing. In part, that is like sometimes, well, a lot of the time, Apple don't give you any notice up front about what's going to change. And on top of that, not only do they not give you any notice on what's going to change, they'll make changes on their server that you'll only find out about when you are deploying your code to Apple at the end of your builds. And so these are the kind of things that like previously were not problems before using frameworks.
Yeah, and you know probably yourself from building your application and ensuring that everything runs smooth. There are limited possibilities to really catch everything in your continuous integration, and with an open source project, we are even further limited, and we can't, obviously deploy automatically to the App Store in our continuous integration. So, we really rely on some points on user feedback, but we are luckily getting a lot of it. So.
Yeah, a lot of it. Okay, so where I work, I've transitioned 3 major applications from CocoaPods static libraries to CocoaPods frameworks. And so I wanted to give a rough gist of like the process of how I've ended up doing this in general. Marius says I shouldn't be recommending this entirely to people because we have a proper way of like migrating projects. But what I do is I use one of these crazy plugins we were talking about that completely nukes CocoaPods from your project. So CocoaPods deintegrate, and then I run it, and I use this when I'm switching between frameworks and libraries, and from libraries to frameworks. So it ensures you have a really clean slate when you're running pod install the next time, which is what I would recommend. So this is what it ends up looking like, and it goes through all these different parts of where CocoaPods touches your Xcode project and shows you like what has changed and what is changing, and gives you a good idea of what has created a clean slate. And that is roughly deleting the pods, changing some of the build phases that we mentioned earlier, and finally just removing any empty Xcode groups that CocoaPods will have made. From there, it's actually as simple as these 3 steps, which is use frameworks in your pod file, and that will then dictate that the next time that you do a pod install, it will switch to libraries to frameworks. And then, of course, you run your tests, and that's where you then start to find out where all the failures are. Woo! So from doing it myself, these are like the most common problems. And that is that like pods that depend on other libraries that are not yet dynamic. So most people will have seen this from like Google Analytics or other like very big popular non-binary distributed libraries. Flurry is another one. It's nearly always analytics libraries. To some extent, you just can't work around that. We've ended up, on my end, I've ended up adding app code that kind of links 2 pods together in order to make that work. The other one is to just actively bug whoever is distributing that library that maybe they should start supporting frameworks now that it's been a year. But to some extent, on their perspective, it's also a bad thing because they also have to then dictate that they're going iOS 8 and above only. So there's definitely reasons for people not migrating in that direction. We often find that libraries don't look up their own bundle resources. So instead, they just presume that it's already inside the main app bundle, which means that you end up with missing images most of the time. I found that with fonts, we have pods that give us our fonts, that like we then had to entirely dynamically link them because we couldn't even rely on putting font names in our info.plist. And then there's the crazy stuff that people used to use with pound defines that would allow them to like do whatever the hell they want with allow you to do whatever the hell you want with someone else's code. We saw a lot of this with like custom prefixes where someone would have a pound define that would allow you to remove the custom prefix. That will just not work full stop anymore. Shame. So one of the apps that we translated was actually one of the first apps to ever use CocoaPods is frameworks, because the moment you got a commit that was workable, I just started shipping it, bleeding edge on one of our apps. And I've got the pull request up there. So one of the advantages of where I work is that we do everything as open source. So you can go and look at the pull request of the transition from a static library to a framework. This one's the first time we started doing it. It's one of our projects called Eidolon, which is a Swift app. So it was kind of nice and easy because it was already in that process. The next one was our oldest app, which was by the point we migrated was about 4.5 years old. So there was definitely a lot of legacy code in moving it over. And that transition probably took me about 2 or 3 days. of like editing pods and changing our internal structure. Again, this is open source, so you can also go and see the pull request changing these things. Then finally, we had our most complicated application that had over 60 pods in it. That's a bunch of those are internal, a bunch of those are testing, and a bunch of those are like open source ones. And transitioning was a little bit difficult. This one took about a week or so of like someone who knows how to use CocoaPods well time. But part of that was then made extremely difficult because maybe roughly a week or two later, we realized that the launch time was so bad that every time you would click the app, every time you clicked the app for the first time, it would like entirely time out. The watchdog would just kill it. It would stay there for the full, I think it's 8 seconds before watchdog kills it.
I don't know exactly.
6? 10? Whatever. It's a large amount of time. It's really frustrating to watch. And we transitioned it, and it turned out to actually be the switch to frameworks, where we're finding that this, like having 60 pods roughly linked into your app at launch time was just not actively working for us. There's a really big pull request that is still not finished, where we have multiple developer tech support issue requests with Apple, and there's many radars about this now. That is like a genuinely prohibitive problem. It looks like this, and my eventual fix was to actually convert it back. Like as an application at this point, we were not using Swift, we were not using extensions, so there was no like strong reasons for us to actively use it. We were just switching to frameworks to be ready in case we wanted to. So even now, you can definitely ship an app that does not require you to be using frameworks. It's nice that they're there, but you don't have to use it if you don't need to use it. So remember to rate this session and rate CocoaPods frameworks as being awesome. And plus, as there's 2 of us, you'll have to remember that we're extra super cool. And you can come and help us out at CocoaPods, right? This link that we just made a second ago will take you to like what we call the easy first issues, which are things where like people that do not know Ruby can start making a stab at some of these smaller bugs or smaller like feature requests that we as the actual people building CocoaPods generally don't try and take so that other people can go and get them. So I would strongly recommend doing this, and I strongly recommend helping us out.
Yeah. Please come and help ourselves. Very welcome.
Thanks.
So we got a couple of questions from the audience. First one is, what's your opinion on Carthage, and why is CocoaPods the better dependency manager?
Actually, this question is kind of difficult to answer, at least the latter part without taking too much time. So I would say both dependency managers are very different in the way they try to achieve their goals, and CocoaPods tries to make the whole integration and the whole thing, what's going on, as transparent as possible to the user, so that everything is inspectable and everything is like you used to have it in Xcode, and you would set it up on your own, and even the build process is just used as what Xcode is giving you. So and it makes it easy to ignore Xcode about that, because you don't need to have an actual working Xcode project to have a working pod spec. So if you don't like to have state and maintain information in Xcode projects, pod specs are definitely a better solution for you. And Carthage is going a different way at this point. And with 4 platforms, I think we prefer for us and the community the way we have chosen, and we're happy with that.
So yeah, I think you covered this, but there's how much an increase of load times did you experience with apps being converted?
Yeah, that was like the Tumblr app. They posted on there that I think they said they went from like roughly 0.3 seconds to like 5 or 6. Which, yeah, exactly. It's that point where you're like...
So the takeaway from your session is really that you can use frameworks now, but don't?
I mean, there's a lot of apps that must be shipping with it. I guess the answer is maybe like you're gonna have to have a crazy hybrid solution of some frameworks and some static libraries.
I think it really depends on your use case and how you use dependencies and how many of them. I know about the Artsy projects that they're using a lot of dependencies and a lot of third-party dependencies, which are not actually third-party, because they maintain a lot of open source projects on their own. So if you have very, very much code scattered over a lot small libraries, then it will definitely have an impact on the loading times. But if you have a small amount of rather big dependencies, then you could actually profit in the loading times, because a very big executable takes longer to load than a small executable which has some big dependencies.
Yeah, remember n squared. So effectively, like the more it gets significant, but while it's still small, it's pretty reasonable. Like we're still shipping some apps that have frameworks turned on, or multiple, but the big ones, no, for the moment.
Questions from the audience? Yeah.
That was really nice that you tried the Swift version of CocoaPods on your own apps. Do you have like a test app that you send off to the App Store with like every version of CocoaPods? Just to make sure that Apple still accepts what you guys are doing new?
No, we don't do anything like that, because there's just no proper way to do it.
So if there's a problem, somebody's going to call you like, hey, ship this app, then where Apple said no.
Exactly, yeah. We try to prevent it by having some experienced developers in place for code review in our core team, and using the technology we built on our own. But there will be always edge cases, like especially with extensions and really weird stuff like sharing dependencies on a WatchKit extension and a WatchKit app, and having all the stuff in place. It's just now too much, as you're really able to test it by one big integration scenario. So, yeah.
Just an idea for somebody who has a lot of free time on their hands. Why not a continuous server that just checks out the latest version of CocoaPods, builds a project, and sends it off to the App Store, just to make sure that it goes through review again?
So if you can make that work without being able to discard versions from iTunes Connect, then
yeah, because you've got no guarantee that Apple are gonna.
The tooling on the web hand side of things is going to be problematic, but yeah, with the tools around Fastlane, it could be eventually doable.
Let's get Felix. Felix can do it. He'll probably just do it in a day if we ask him politely.
So one of the standard questions I get when I recommend people CocoaPods is, okay, so what should I check into Git? Check in just the pod file, the entire pods? What's your current?
I'll let you, because I got different opinions.
I mean, we can both answer this question, but
yeah.
So there, I would say it depends, but I generally prefer having the pods directory in place, because that's nice for continuous integration, because it doesn't have to run pod install, and you make sure that even when on some pod a force push to master would be run, and there's a different version up there, or just new commits for the same version, that could happen. I mean, we rely on tags in the repository, and you can change the tag with Git when you do something bad, like a force push. You shouldn't do that, but the code could change, and you could get something different, and you can prevent anything like that, because once you have the pods directory in place, there is no need to run CocoaPods at all, or to have CocoaPods even installed. So you're much more independent with having the pods directory in place in in some way at least. I know about some developers who came up with using Git submodules for the pods directory specifically.
It's kind of ironic, right?
Not that much. So your answer?
In all of our apps, we don't. In all of our libraries, we do. Like libraries, you actually get Carthage support for free, more or less, if you're doing that. And a lot of the time, you will come back to a library after a long amount of time in between. There's also the fact that you can't entirely rely on other people hosting your code that you'll be bringing in. So checking in your pods means that you'll actively have the code that is necessary for your app every time, in case like Twitter decide to take over the Twitter pod and suddenly decide that they're not going to support all the old versions of the unofficial Twitter SDK. And so if you'd have checked your pods in beforehand, you'd still be able to rely on that code existing in your own fork, well, in your own repo, effectively. But in general, the applications that we work on where I work is that like these are permanently developed applications that are constantly going to have development done on them. So when a pod disappears, then it's very likely we'll have found out by the next day, and we'll have found a mitigation strategy for that problem. And so it doesn't have the clutter of it being inside your code reviews, as well as like we include our application keys inside our pods directories. So like we have sensitive data in there too. So there's a bunch of like yes and no reasons, which is why a lot of people ask the question. Like, there, in my opinion, there is no strong answer for one. It's like the multiple paragraphs we have on the guides about it. There are reasons for doing it, and there are reasons for not doing it. You should find your own space for it.
Yeah, definitely.
Right? That's the most important part. I'd like somewhat... I want to build a new website on CocoaPods, but I don't want to be the one building it. So I just want to do all the designing. So if someone really feels up for building more Ruby websites, that would be cool. Want to build something that's a bit like Medium, but for talking about pods. So I haven't quite found the name or the terminology I want to use to describe it, but I think that would be a nice way of like collating them together. So you could say like these are the certain pods that I think go well together or they compete, and this is why. Like just think how many functional reactive programming pods are there out there. There's maybe like 5 or 6, and nearly all of them are worth your time, but all of them have trade-offs, and this website should be the way in which people can express those. That's what I would like to see.
I would like to see, well, some of the easy issues tackled, but also one thing I spoke about, like we use this embed frameworks built fast because we want to still enable configuration-dependent pods, but would be nice if we could automatically recognize when no configuration-dependent pod is used, that we just use the copy files resource files instead, and let Xcode do their job, and not our kind of fragile script where we try to reproduce to do the same, because there's no official tool from Apple where the functionality there is exposed, so that we could reuse that. We have to replicate everything what is done there effectively, and do it on our own in the shell script. And yeah, that has shown to be error prone in the past, especially with Apple changing around things and tweaking stuff. So I would like to have the integration as close as possible to what's the way Apple would do it.
I'd like to double that. That's all good and proper, but every time you press build on a CocoaPods project, you see this little running script phase. Fixing that problem would remove that problem for everybody. There are roughly 40,000 projects using CocoaPods. If you could do that, you would save like maybe a second or so from every single person pressing build every time. That's a lot of time. like, and it's totally worth someone's time to build. But build my website first. All right, thanks.
Thanks.